Good afternoon. I'm Chris Keach, and I'd like to welcome you to today's webinar, SpecSizer 101 Basics to Get You Started, presented by Caterpillar. Before we begin, I'd like to make a few brief announcements. First, this webinar is being recorded and will be available on demand for 1 year. Please share it with your colleagues if you find the information helpful. Second, our webinar is designed to be interactive, so please be sure to disable any pop-up blockers you may have installed, as they may interfere with certain aspects of our web conference. You may also download a PDF version of the slide presentation by clicking on the user guide, which is the green folder icon located at the bottom of your console. You may also ask a question at any time. To submit a question, please click on the Q&A icon at the bottom of the screen, type your question into the question box area that appears, and then click the Submit button. Now I'd like to introduce today's speaker for the webinar, Stephen J. Baker, Market Development Consultant, EPD Marketing. Stephen leads the development and training for Caterpillar's generator set sizing tool, SpecSizer. Stephen began his Caterpillar career with machinist and degree option apprentice programs and received his university degree from Bradley University in Peoria with a BS in Engineering and MBA Foundation. He graduated to factory supervisor, later working as a manufacturing and systems engineer, and then as NPI Program Project Manager in the SEP Small Engine Group. Stephen joined Electric Power in 1999 as Retail Assistant NPI Program Manager and led 6 Sigma projects as an Electric Power Black Belt, transitioning into his current role, managing the sales tool, development, support, and training for generator set sizing. Welcome, Stephen. I'll now hand it over to you to begin today's presentation. Stephen?
Yeah, thank you, Chris. I'm appreciative of this opportunity today to talk about SpecSizer and cover some basics for you. That's what today's presentation will do. Okay, so now we're going to talk about user preferences. There's about a 4-step process that you use when you size a generator set. The first thing that you need to do is set your user preferences in SpecSizer. User preferences, all that is your default site conditions. Okay, let's take a step back here and talk about if you're in today's webinar, you already have access to SpecSizer. You know the URL to register for SpecSizer, specsizer.cat.com. But on that same landing page is the URL to access SpecSizer. There's the URL to register, the URL to access SpecSizer. Once you register, you'll be provided with a user ID and a temporary password upon your first access to SpecSizer. Then you can change your password. And then we also have a short training video that you can use that covers a lot of the material that we talk about today. Now let's talk a little bit about user preferences. As I said, it's the default site conditions that you use to size your generator set. Okay, here we see in the top section, user preferences has a top section and a bottom section. Here we're talking about the top section. You see a lot of user ID information, and if you see information that tells you that information is editable. You also see down below, you see some pull-down information for your region. New to the SpecSizer web tool is the capability of the user to change their region setting. And why that's important is you may be working a project in a different geographical area of the world, and here we allow you to change your region setting to align your genset list selection with the product available in that region, as you can see there. Okay, now we see the bottom section of the user preferences. What we're looking at here is the generator set duty. SpecSizer allows you the ability to size your genset as a prime, standby, or continuous genset. We've also got the setting for the altitude and the ambient. With the web tool, we've made it possible to see not only the English but the metric setting. So when you change one, you change the other. Now it's important, altitude and ambient is important because if your genset is at high altitude or high ambient, your genset's going to derate. So I get that question a lot. Does SpecSizer derate a genset? And the answer is yes, it does. And here's where you control your altitude and your ambient. And then a little bit later on, we'll look at a select genset page, and you'll see that if the site genset EKW KVA rating is less than the factory, you'll see where the genset actually derated. Now here we're looking at a selection of filter for genset product. This filter is available for all regions except the United States. This filter provides not only the Caterpillar product, genset product, but the CAT Compact International product. Now you'll see this filter for every region except the United States. You won't see it for United States, but for United States you'll see a filter for UL listed gensets. Okay, now here we see pull down a filter for languages. SpecSizer has 8 languages: English, Chinese, French, German, Italian, Portuguese, Russian, and Spanish. You can come back here at any time and change your language. Just remember, save your selection, and then when you advance in the tool to your site conditions and to add loads, your language will be changed. And you can always come back here at any point in time to your user preferences and change any of these defaults. Okay, so now we've moved on. What have you done? You've gone in, you've accessed the sizing tool for the first time, you've set all of your user preferences, you've set all of your defaults. Now you're just simply going to decide whether you're going to create a 3-phase project or a single-phase project on this page, the My SpecSizer page. And here's where you also do your folder maintenance. Okay, so here you can see where you can select a 3-phase project, and here you see all your different folders that you may have created. Well, here we're looking at the bottom section of the Define Site Conditions page. As I mentioned earlier, all of the settings on the User Preferences page download automatically to the Define Site Conditions page. So, for the most part, you're seeing the same settings here on Define Site Conditions that you see on User Preferences. You got a few that are different here. I'd like to just talk through those for a moment here. What we've got highlighted first is a feature called % of intermittent motors. And why is that important? A lot of your loads in your load scenario at your site will be motor loads. And if you've got motors that start and stop, it's important to apply what we call a diversity factor. So this is something that, some logic that we provide. If you've got a motor load that starts and stops, you check that motor as intermittent on its load dialog. And then here's a feature where you can, between 25 and 100%, you can specify what percentage of those motors start at the same time. So you determine it, and what that will do then is create what we call an intermittent step on your Add Loads page. And that then will account for those loads that start at once. It's a diversity factor. Now here we're looking at expansion capacity %. This is a new feature that we provided with the online SpecSizer tool. I've seen sizings where the genset was sized at near 100% capacity, say 98.7, and you'd ask yourself the question, why would you install a genset that was at near capacity? So this is a feature where we look at the ratio of your motor versus your nonlinear loads, your motor versus your non-motor loads, and your linear versus your nonlinear loads, and we apply logic for those ratios. It's not just straight linear loads, it's not just straight motor loads. So we allow up to 30% capacity, and it's important to understand that if your load scenario sizes a genset that's lightly loaded or prone to wet stacking, loaded at less than 30% capacity, this rule will not take effect. This feature will not take effect. We're not going to cause your genset to be even more lightly loaded. Okay, the last thing that we're going to talk about here on the Define Site Conditions page is an input called voltage regulator. SpecSizer is a full transient response tool. We get factory Genset transient response tests, and we get them not only at what we call a standard voltage regulator slope, but at an optional or an optimal voltage regulator slope, say a 3-to-1 slope. And we load both sets of transient response data into SpecSizer. The tool is set on best fit, will automatically compare both sets of transient response data and select the smallest genset for you, the smallest EKW kVA rating. Now you can force the selection to be either 2-to-1 or 3-to-1. 2-to-1 is the standard, 3-to-1 is the optional. But you have the latitude to either stay with the best fit and let the program do the comparison, or size on a 2-to-1 or the 3-to-1. So really what it is it's a competitive sizing factor for you to size the smallest genset possible based upon the performance of the voltage regulator.
Stephen, we do have a question for you. What the question is here is, when selecting the type of voltage regulator, why would I want to specify a 3-to-1 slope versus a standard best fit?
Okay, that's a good question. You know, there are times where you've already got a purchased installed genset, and you're using SpecSizer to evaluate whether adding loads is going to cause your genset to go over capacity or not. So here's an opportunity. If you've got a purchased genset that's set at a standard slope or set at an optional slope, you can force the tool to align with your voltage regulator setting to see if you can add those loads and still not be over capacity. And I'll mention another thing. I've seen sometimes on a few inquiries over the years where we've got some reports that you can generate with the SpecSizer tool. There's a report called the Transient Performance Report, and I've seen some times where I've gotten a call or I've gotten an email and the user would say, the Transient Performance Report tells me that the genset fails, so what do I do? Well, really what this is telling you is that using the standard voltage regulator, the genset couldn't or didn't pick up the entire load in one step to be in compliance with NFPA 110. So if you go back and set your voltage regulator to 3-to-1, you get better transient performance with the 3-to-1 voltage regulator, and that note will then go away. Okay?
All right. Thank you, Stephen. Continue on.
Yeah, thank you. So now we're going to, we've talked about your user preferences, and we've talked about defined site conditions. Now we're going to talk about really the second step in sizing your genset, which is to add your loads. So you move to your Add Loads link here, page, and what we're looking at here is really three sections. Let's talk about the first section first. It's the step load list. This is where all of your step maintenance is done. Okay. The second section is your load list. Anytime you go to a load dialog, a little bit later we're going to look at how you add a load to SpecSizer, but when you add a load, it will then appear here on the Add Loads page. And here is where you can also do your load maintenance. You can simply click on any load in the load section and bring your load dialog back up. Okay? Now you're looking at the section where you on the Add Loads page where you actually see your transient response. In the top section, you'll see what we call the effective frequency dip and the effective voltage dip. And in the bottom section, you see that as well as your user-defined transient response. Now, why this is important, this was something new that we did for the web tool as well. A little bit later in the presentation here, and also especially in our 201 course that we'll do a little bit later as well, we'll talk about something called restrictor frequency dip and voltage dip. And what that's about is if you have a load that has restrictor transient response, restrictor frequency dip or voltage dip, a low number like 10%, all of your later subsequent loads will adopt that restrictor transient response, And what will that do? That will cause you to oversize your generator set. So it's important to see that effect on your loads and how the transient response, and see how your user-defined transient response changes. So here's where we do that at. In the top section, you can see where an earlier load will have caused later loads to adopt a restrictive transient response. And in the bottom section, you'll see both the user-defined and the effective transient response. All right, now we're going to talk a little bit more about the add loads process, adding loads, adding steps, and we're going to talk about also optimizing your load. So what we see here is a snapshot of what your add loads page would look like. We're looking at adding a load here. There's two ways that you can add a load. You can use the Add New Load button, or you can use your icons. Okay, here's your loads as if you would add them with your Add New Load button. Okay, and here's where you use your icons to add a load. SpecSizer has about 15 different load types that you can use to size your generator set. Now, I prefer to use the icons, but again, you can use either one. And one good thing about the Add New Load button is that we have developed what we call a template load or a library load. If you've got a load that you use frequently, to align with some spec, on the load dialog for that load, you can create a template or a library load, and all you would simply do is highlight over that load. When you access a load with the Add New Load button, you would highlight over that load type, and you would see your template loads. Okay, here we're going back and we're looking at the, adding a step to SpecSizer. To do that, you simply click the Add Step button. Okay, and you can see here where you have the ability to copy a step or the ability to delete a step. Okay, here we're also, I just talked about this. I talked about effective frequency dip and voltage dip. That's the restrictive dip. Okay, it's important to understand that a couple of things here are really important about sizing your genset. I'll talk more about this later, but you don't want to sequence all of your loads into one load step if possible. I mean, if you need to do that to align with your spec, okay, but if you don't have to, multi-sequence your load steps. Have more than one. In addition to that, make sure that you sequence your loads that have the tight or the restrictive frequency dip or voltage dip later. Okay, and here that's all we're doing is showing you that again.
Now, Stephen, we do have another question for you. If the optimizer selects the smallest genset for my needs, why isn't it automatic? In other words, why do I have to turn it on?
Okay, there are times where there are just simply times where you won't want to look at the optimized genset. You may have to really align with a specification. Your loads may need to be sequenced in a certain order. So, what I tell users is, I would say always look at the optimizer, always check it out. With SpecSizer has really been available out there for about 10 years, and I've worked really thousands of inquiries over those years. And the first thing that I would always do in working an inquiry is run the optimizer. Back at that time, it was all manual. It wasn't automatic. And 35 to 40% of the time, I would see that just simply by running the optimizer, you could downsize your genset. You could size a smaller generator set. But there are times where you have to align, you have to adhere to your specification. You have to have a load that's sequenced as per a certain load step. And so what I say then is go ahead and it's optional. You can check it out. The optimizer runs in the background automatically, but whether you check it out is optional. But if you run it and your loads are resequenced in a way that doesn't align with your spec, you can always move your loads to align with your spec. Okay? Okay, now we're going to talk a little bit about really what's going on behind the scenes here when you're sizing your loads. You're really looking at mostly only two components of the generator set when you're sizing a genset for an application. You're looking at your engine and you're looking at your alternator. And the way I look at this is that anything KW related is synonymous with your engine, and anything KVA related is synonymous with your alternator. Okay, so you've got different sizing parameters that your loads will calculate. You've got your running KW, you've got your starting KW, those are the engine. You've got your running KVA and you've got your starting KVA. That's the alternator. So if you've got more of any of those, you require either a bigger engine or a bigger alternator. We've also got a value called TKVA that we calculate. It's your alternator KVA plussed up for harmonics from nonlinear loads. So if you've got more of that value, then you also require a larger alternator. Okay, so those, that's how those sizing parameters really relate to each other. And when I'm working an inquiry, and when I look at that, then if I'm trying to downsize the engine, again, then I work with the KW, and if I'm trying to downsize the alternator, I'll be working with the KVA values. Here, I just want to talk about motor loads. I want to spend just a minute talking about motor loads and why. I mentioned earlier that they create a lot of inrush, 4 to 5 times a non-motor load. So it's important to understand the impact of sizing motors on the size of your genset. You can readily oversize your genset if you don't look for opportunities to reduce the inrush that your motor loads cause or create. So one way to do that then, when you would go to your 3-phase motor dialog, you would look at something called starting method. And there are multiple starting methods. Direct on line and across the line are the most severe type of starting. You've got other types of starting methods like variable frequency drive, variable speed drive, auto transformer, saw starter. And these type of starting methods then can and will reduce your inrush. They will reduce your starting KVA and your starting KW, and they'll reduce the required size of engine and alternator that you need. Okay, so here we see the pull down then for the starting method, and we see the different kinds of reduced voltage starters. And it can be significant. Just look at the Y delta there. Y delta starting method will reduce your inrush 67%. So it's a important, significant opportunity for you to right size or better size your genset. Another load I think that's noteworthy to talk about is the UPS load. Back last year, we simply had what we call a generic UPS load that you could size in SpecSizer. Last year, we added the cat battery UPS and the cat flywheel UPS load to SpecSizer. So it's an opportunity then, you decide it's an opportunity for you to utilize all the opportunities that are out there for you to select the best UPS for your application.
We have another question for you. What is the advantage of sizing CAT's UPS versus other manufacturers? Can you talk a little bit about that?
Yeah, it's a good question. The advantage of using the CAT UPS is a lot of the generic UPS, it's just generic data, where with the CAT UPS, we have the data. We can better size for the harmonics, for the distortion, because we have all that data for the CAT UPS, for the CAT battery, and the CAT flywheel. So we can get a better representation of the effects of the harmonics and the distortion on that load type. Whereas the generic UPS, that could just be really anybody's UPS. So really what we started talking about when we started talking about SpecSizer sizing with a genset, sizing software is accuracy. So you want to be as accurate as possible. And if you've got the data, if you've got your own data, then that lends itself more to accuracy, accurate sizing. Okay, what have we talked about here? We've talked about user preferences. They're the default settings for site conditions. We've talked about the two sections in site conditions, general settings and, project-specific settings. And we talked about, adding your loads and, sequencing your loads. And I talked about how important it is to, not size all your loads in just one single load step. It'll oversize your genset. And I talked about how important it is to look at how your loads are sequenced with respect to, frequency dip, voltage dip, tolerance. Once you've got your site conditions defined and you've got your loads added in sequence, then all you have to do is click on Select Genset. You move to the Select Genset page and you size your genset. It's that easy. You can also click the Continue button at the bottom of the Add Loads page, and then that will then move you to your Select Genset page as well. So, I've been talking about a couple rules of genset selection here. I've been talking about the restrictive frequency dip and voltage dip. And I really want to stress the importance of understanding that. We talked about how you see effective and user defined on the Add Loads page, but it is really, really important to make sure that you don't sequence a load with restrictive transient response early in your load scenario if you don't have to. Again, you may have to according to your spec, but don't do it if you don't have to, because I can't say enough. For example, if you've got a medical load, it's a life and safety load. We don't allow you the full range of transient response setting, frequency dip and voltage dip for a medical load. It's 10% max, again, because it's life and safety. If you sequence a medical load in your first load step and you have motor loads after that start after that, and they could be sized at 30% voltage dip and frequency dip, what's going to happen here is all of your motor loads are going to adopt that 10% frequency dip and voltage dip of that medical load, and you will oversize your genset. So, pay attention to it. Don't do it. I call it the cardinal rule of sizing. It doesn't matter whose sizing tool you use. You can size a genset manually by hand. This is still going to happen. The other, I call it cardinal rule of sizing, is RKW rule. I mentioned this earlier, I think. And that's that your genset, your nameplate rating of your selected genset, it has to meet or exceed the RKW. That's the engine size RKW. So your loads, you enter your loads into the tool. Different sizing parameters are calculated starting and running. The starting is SKW and SKVA. The running is RKW and RKVA. Well, your genset rating, again, it has to be bigger. It has to at least meet or exceed your loads calculated RKW. And so, our gensets, we don't uprate them 1 kW at a time. Usually it's by 25 to 50 kW. So all this is telling you is that your genset has to be bigger than that RKW, calculated RKW. Okay, this is just showing you that once you click on the Select Genset page, you size your genset. It says Load Optimization in Progress. Okay, here now we've moved to the Select Genset page. You can see that whenever you move to the Select Genset page, you're highlighted on the program selected genset. You can see there circled Go to Best Fit Genset. If you click off your program selected genset, you can always find or go back to the program selected size genset by clicking back on the Go to Best Fit Genset link. Okay, but you can also manually size your genset, and the way that you would do that is pick any genset row, and click on or select the underlying rating in the factory Genset EKW KVA column. Okay, so, sometimes I've gotten a question from a user. They say, well, I need to print reports for a Genset other than the program calculated size Genset. Well, again, what you do is you go back and click the underlined rating, and then you can move forward. A little bit later here, we're going to talk about reports and how you access them by going to the to that data and reports link. But make sure that you click the underlined rating, and then your reports will be for the Genset that you manually selected. Okay, and here all we're doing is showing the best fit Genset, always highlighted in color. Okay, the optimizer, I think this is an important section. I've kind of danced around this a little bit. I said that at one point in time it was always manual, a decision that you would make manually on whether you would run the optimizer. Back in the old days it was called the Wizard, but there were just so many times that I would see if our customer knew that feature was there, ran the Wizard, ran the optimizer, that there were so many times that they would see a reduced size Genset, smaller EKW KVA, 35, 40% of the time. So what we did when we developed the online web tool, we developed logic so that the optimizer or the Wizard runs in the background all the time, every time. So when you click the select Genset page link, it kicks off that optimizer. It starts that optimizer running. And so, you'll size a Genset based upon your load scenario, based upon the loads as you sequence them. But you can always then go and you can click the Go to Optimize Scenario link, and you can run the Wizard, you can run the optimizer, and you'll see what the program can do for you as far as sizing a smaller Genset. So what it does when you click that link is take you back to the Add Loads page, okay? And so you'll look at then the load scenario that the program has changed to, and then you have an opportunity then to go back to the Select Genset page. So what we're looking at here then is a comparison, just a sample comparison of what your load scenario may have looked like before you ran the optimizer and what it looks like after you run the optimizer, okay? Your loads will be resequenced. Okay, now you can always back out of that. You don't have to accept that, but you can. You can accept that optimization of your Genset. So, what we're looking at here is we're back on Select Genset page, and I just want to talk about a few things that you see here so you have an understanding. There's a lot going on here on the Select Genset page. What we're looking at here is the best fit Genset is always highlighted in green. If you click off of it, off that row, it turns blue, and you can see there on the bottom, you can see a legend of ratings where you can advance either one page or you can advance all the way to the top of the ratings. SpecSizer right now is a diesel tool. It sizes diesel Gensets, and the largest rating in SpecSizer today is a 4,000 kW KVA Genset, a C17520. So, but that's at 4160 volt. So if your site conditions are, say, for 4160 volt, not 480 volt, 60 hertz, you could jump all the way up to the top rated Genset, or you could use the min rating, and you could go all the way down to the smallest rating, 10, 13 kVA. So it's just a legend that you can use to move back and forth on the different pages.
All right, Stephen, we do have a question on this. How do you know what your Genset sizing is based upon?
Okay, we talked about the different sizing parameters, your starting and your running and your harmonics. On your Select Genset page, there's a note and it is called Selection Criteria Note. It's in the top right-hand corner. And whenever I would work an inquiry, I'd get an email or a phone call from a dealer or a customer, and basically when I'm contacted, someone wants to size a smaller genset. And the first thing that I do is I look at that selection criteria note, and it will tell me the load step that sized the genset and the reason. So I might see something like, step number 3, voltage dip restriction. And so that tells me then to go back to the add loads page, look at load step number 3, look at the loads that are in that load step. And typically if I'm working with voltage dip, I know that it's motor loads. Motor loads cause a lot of inrush, cause a lot of voltage dip. So again, it's that selection criteria note that tips me off as to what size the genset. So here we're back to the select genset page, okay, and you can see there, you can see the size genset is, all the information for the size genset is up there at the top, and you can see again the legend at the bottom, and you can see some other buttons there. You can see compare selected, and that then we haven't really talked about that yet, but really that's a new button, a new feature in the tool where you can look at up to 4 generator sets. You can compare up to 41 different attributes or data when you compare gensets. So again, there's a lot going on here on the select genset page. Okay, especially back there on the select genset page, at the end of every row is a command called view. And so if you click on view, then you can advance to another page called generator set details. And there are 3 pages available with generator set details. The default page is starting in selection analysis. There's also an alternator frame options and a diagnostics page. So let's talk a little bit about starting a selection analysis here. You see the transient response of the loads. Again, you see the selection criteria note here as well as the select genset page. And you can, if you're looking for, we talked earlier about the voltage regulator. Here you can see the effects of the 2-to-1 standard versus the 3-to-1 voltage regulator. There's a side-by-side comparison there in the table in the middle of the page. And there are times where you will see that the 3-to-1 slope voltage regulator sizes a smaller generator set. Okay, there's also the alternator frame options page. Okay, I was doing some training down in South America. It's been a few years ago, and our Caterpillar dealer asked me if there was a way that they could determine whether the size genset's alternator was an oversized alternator or not. So I came back to Peoria, my home base, and I thought about a concept of that. What's a way that we can do that? And so what we did was we created a table here called alternator frame options. And what we do for the user is present all of the alternators that will work with your program selected genset. So we show you all the alternators and associated data and the RKVA value for that alternator. In addition to that, over the years, being a SpecSizer manager for 10 years, I've really worked thousands of inquiries for customers and dealers, and I was always looking for a way, what's important to you is important to me. You want to work as quickly as you can. You want to work as efficiently as you can. And so I was always looking for a way where I could get access to system information quickly. And so I created this page I called it Diagnostics. And so what you see here then is you see a lot of information or data that's associated with the genset, with the engine, the alternator, and also some project type information, all for the program selected genset. So down in the project information, you'll see when you first created the project, and when it was last modified as well. So a lot of good information. If you're working with your Genset, maybe to change something on your order, or again to try to understand why the Genset sized the way that it did, this is another page that you can go back to, and you can look at data tied to your Genset sizing.
And Stephen, we do have another question for you coming in. This viewer is asking, are the generator set details available for every Genset in SpecSizer?
Yes, that's a good question. Yeah, they are, but remember, in order to see them, you have to click the View command on the row for the Genset that you've selected. Okay, we basically have sized our Genset at this page. What did we do? We specified our site conditions. We added and we sequenced our loads. We selected our Genset. We looked at the Genset details. We know what the selection criteria was based on. Now we want to create some reports. So let's just talk about data and reports here. That's the fourth page, the fourth link with the SpecSizer application. 3 different types of reports that you can generate with SpecSizer: the project sizing report, the load report, and a transient performance report. Here we see the project sizing report. Another opportunity for you to see all of the technical information that's associated with your size Genset. Again, engine, alternator. Another valuable section here, information for me on this report, is a section for block load transient response. Do you remember that I mentioned that SpecSizer is a full transient response tool? These are not fudge factors that we use for transient response. We actually factory test our Gensets. Actual iron, I get that transient response. Remember I mentioned that we get it at not only a standard slope, but an optional slope. Well, that is loaded into the tool. So here you see the transient response of your selected Genset at 25% load change increments. You can also see some information related to your alternator motor starting capability. For me, this is important. If I'm working a Genset that is sized based upon voltage dip restriction, I can kind of go here and interpolate and look at SKVA capability of my alternator and how it relates to my sizing. So a lot of good technical information there about the Genset. So now we're looking at the project load report, and I think some value-added information on it is for every load step we provide a transient response graph. Okay, it's not a dummy graph, it's an actual graph drawn based upon your data. But in addition to that, I mentioned that somebody has to work these inquiries, and a lot of people we're looking at optimizing your Genset. And so what we do is we box the values. Say you've got, SpecSizer will size up to 99 loads and 99 steps. Say you've got a sizing that's 40 load steps, and you would like to know for your starting KVA, what load step should you work with to reduce your starting KVA, to reduce the size of your alternator. And so what we do is we box the values that are highest, so you know right which step to go to on your add loads page, which step to work with to reduce any sizing parameter, whether it be your starting kW for your engine, your running kW for your engine, your running kVA and starting kVA for your alternator. Now, the third report that we provide is the Transient Performance Report, and it's basically broken into 2 different sections. The top section is the load step that sized your Genset, its transient response. And the bottom section is a block load factory Genset transient response test. And again, it's at 25% load change increments. When we tested Genset in the factory for transient response, we tested at every 5% load step to better accurately document is transient response. So this is a report of the genset that you selected of its transient response. And do you remember that earlier I talked about there was a question about voltage regulator? And I mentioned that here in the bottom section of the transient performance report, if you get text that says failed in red letters here, really all you need to do is you go back to define site conditions page, go to the voltage regulator drop down, change your voltage regulator to the 3-to-1, which is our CDBR, our adjustable voltage regulator. It has better performance, and then that note's going to go away. And really all it meant is that with the standard voltage regulator, you weren't able to pick up full load in one step, according to NFPA 110, transient response. It's a North American spec.
So, Stephen, looks like we got another one for you here. How do you print reports for a genset other than the program-selected best fit genset?
That's a good question. Really a few too many users have gotten tripped up on that. And remember I talked about on the select genset page, there's a column, factory genset, EKW, KVA. Select the underline rating, and then that'll give you access to your manually selected genset to print those reports. If you don't do that, if you don't click the underline rating, then you're still going to get the program best fit selected gensets reports. So easy enough. What we're talking about now is we've sized our genset. We know how then to access and print our reports. So we're going to talk about how do I share my file with another SpecSizer user. There's really a couple places in the tool that you can do that. If you're on the My SpecSizer page, remember we were looking at when you first start, you create either a 3-phase project or a single-phase project, and you've got all your folders, and you do your file maintenance there. Well, in each row, there's a edit command, and all you do is you simply click that edit command, and if you've shared your project, whatever number of other users you've shared your project, it'll tell you here. It could be 1, 2, could be 10. And so you click that edit command. It's going to bring up this dialog, and you have an opportunity then to type in another registered SpecSizer user's email address in the box right above the save command. You simply type in their email address, click add, and if this is the first time that you shared that file with that person, their email address will be added over on the right-hand side. Now, if in the past you shared a file with them in the past, their email address will be archived and saved over on the left-hand side, and all you would need to do, you wouldn't need to add their email address again down there to the left of the add command. You just simply click the green plus sign, and that moves their email address over to the right box. And then always click save, and then you share your file with them. Okay. Now they'll get an email that says project sharing notification, and if you click on the link in the email, project sharing notification, that'll take you directly into SpecSizer, directly to the folder of the file that they shared with you, and that folder will be their last name. Okay, so yeah, that's what I'm talking about. How do you find a file that's shared with you? Go back to the My SpecSizer page. There's a command called Shared With Me. It's circled here. You can see that. Simply all you do is click on Shared With Me. It's that easy.
Okay, so Stephen, sorry to interrupt you. We've got another one here on file sharing. The user wants to ask, can you edit a SpecSizer file that's been shared with you? And then also, how would you know if a file has been shared with you?
Yeah, that's a good question. Yes, you can edit that file. I see some users get tripped up with that at times. you open the file and it'll look like it's read-only. All you have to do is save the file under a different file name, and then it becomes editable. Of course, if it's read-only, everyone knows what a read-only file looks like. It's grayed out. So just simply rename the file, and then it will save the file with a new name in on your My SpecSizer page, on that page with all your file folders. I'm sorry, Chris, what was the second question?
The second part of it was, how would you know if one has been shared with you?
Okay, again, that was that project sharing notification. You will get an email, and the title, the subject line of the email will be project sharing notification. And we've made it so that the actual name of the person sharing the file with you is in that alert, in that project sharing notification on the subject line. So just simply click that. It'll link you into SpecSizer and take you directly to your file folders. And then you'll need to look for the name of the person that shared the file with you. Open up the file. It's that easy. Okay? We're going to talk about a few other things here. We're going to circle back to the Select Genset page. Again, what do you use the Select Genset page for? To size your genset. But you can also, there are other types of cell support materials that are available. The first thing that we're going to talk about here is the guide spec. You can go back to the Select Genset page and you can create a guide specification. But there are also other links for other types of cell support material, such as a spec sheet or technical drawings. Okay, and here we're just simply showing, once you click the guide spec link, it's going to bring up a guide spec dialog. There's predefined logic. For example, if you were to size a 1000 kW 1250 kVA genset, there's logic in the program, predefined logic, so there's some compatibility here. For example, it's going to have the right control panel. Everything is going to be correctly configured for you with that logic. However, if there are options, you can select options here on the guide spec dialog. And so simply all you do is make any selections that you determine you need to make or want to make, and then generate your guide spec. And it's a Microsoft Word document that's editable. Now we're just circling back here to the cell support links for your spec sheet and for your technical drawings. There's a system we have that's called Engine Drawing Design Center, and we now provide access for our customers to the technical drawings. Okay, well, we've basically talked about how you size a generator set. There were just 4 basic steps. You specify your site conditions, add and sequence your loads, size your genset by clicking Select Genset. You go get your data and your reports. And I just want to mention as we wrap up here that there's ways that you can get help with SpecSizer throughout the tool. In some places you'll see question mark help. Like for example, I don't know if you may recall this, back on the Define Site Conditions page, there was duty point percent. You can size a standby primer continuous genset. Well, if you would want to know what those are, what are the operating characteristics of those different load factors, you could just simply click the question mark and it would bring up a document and give you some help information. In addition to that, we have an inbox that we set up actually back a couple, 2-3 years ago. And this is more, a venue for our customers. If you have any type of question at all, you can email SpecSizerSupport@cat.com, and that comes directly to me. I man that inbox. And if you've got, first of all, if you've got a technical question, it's better that you contact your dealer first. Your dealer has a lot of capability. But if you've got an IT question about SpecSizer, or you want to just use this inbox, you can email me here at SpecSizerSupport@cat.com. And for example, I can provide you help materials. We talked about percent of intermittent starting. We've got a full page help document on that if you'd want to know more about what it is, or more about any of the inputs or features in SpecSizer. You can email me here. So that's pretty much what we have as far as help is concerned. Okay, I think to wrap up here, wanted to go over some things that you should always remember about sizing your genset. Really, it's not real complicated. I've talked about it 2 or 3 times through the presentation here, but do you remember where I said don't sequence all your loads in one load step? I've seen really very few sizings in the thousands and thousands that I've looked at over 10 years where the application required that all the loads be sized in just one load step. You will oversize your generator set, and then you're likely going to get into that lightly loaded condition called wet stacking. And then you're going to need to look for ways that you can reduce your inrush, like reduce voltage starters or, low inertia motors. Okay, so, avoid one load step. The other thing is pay attention to how you sequence your loads. Remember we talked about the restrictor frequency dip and voltage dip? Let me just go over it one more time. If you sequence a load with restrictor frequency dip or voltage dip, early in your load scenario, all successive loads will adopt that restrictive voltage dip and frequency dip, and you will oversize your genset. And avoid that. We talked about the optimizer. That's one thing that the optimizer does. It basically mitigates that circumstance. The optimizer will look at your load scenario, and it will group your loads largest to smallest voltage dip groups, and within those loads, sequence your loads largest to smallest SKVA. So there's a couple things that you need to do with respect to your add loads page. Multiple load steps, pay attention to your load step sequencing, and then that last thing is the optimizer. Just always at least check it out. Even if you decide you don't want to rearrange your loads, at least always check out the optimizer and see what is the best opportunity. What is the smallest kW, kVA rated genset possible for your site conditions and your load scenario? And really, I know of no other sizing tool that has that feature in it. So it's really a great opportunity for you to see the best value for you. It sizes accurately, and it provides the best value. And again, you can always go back and you can run the optimizer, and if you have a particular load that you need to sequence in a particular load step, you can manually move that load. We showed on the add loads page, there was a feature with some triple bars. You can move steps around. With a coming version of SpecSizer this December, we're going to have a drag and drop feature where you can just drag and drop loads between different steps. So a lot of value there, a lot of opportunity for you, but remember those few basic places where you can get into trouble and oversize your generator set. So that's pretty much what I have.
Thank you, Stephen, and I'd also like to thank our audience for joining us today. Some of you have asked, and yes, you will be receiving an email with the recording site on it after we're done here today. And also, we want to let you know that more training will be available for SpecSizer. This SpecSizer 101 Basics will be followed up with a SpecSizer 201 Intermediate training that focuses on competitive sizing options available in the tool. A better understanding of these features and options can assist you in providing not only an accurate size genset, but a genset optimized for your application. This concludes today's webinar, SpecSizer 101, Basics to Get You Started, presented by Caterpillar. On behalf of our speaker, I'm Chris Keach. We'd like to thank you for joining us, and we hope you have a great day.